Hello, nice to meet you. I'm Young-gon Lee, a professor for Korea Tech University, and I'm honored to be giving a lecture to you. From now on, I will start my presentation on the topic of understanding and utilizing cloud services. In this course, I would like to introduce the basic concept and the types of cloud, as well as the technical basics, and talk about the direction of cloud development and the social use. Through this course, you can understand the basic concept, advantages, and the types of the cloud. Also, you can understand the technical fundamentals of the cloud and the future and the use of cloud. In part 1, yes, I will talk about the understanding and current state of the cloud. In part 2, I will talk about the future of the cloud and the strategies for using it. Now, let's talk about the understanding and the current state of the cloud. Cloud computing is a technology that connects to a network and uses IT resources such as hardware and software without directly building and operating them. If we explain electricity as an analogy, it can be said that in the past, all electricity was used in the form of self-generation, but now electricity produced by power plants is supplied and used in factories, offices, and homes. In other words, the form of borrowing and using all types of computing resources is called cloud computing. Cloud users can directly control computing resources through the cloud console screen. In addition, users can access the cloud through various devices connected to the network. Users can share cloud resources with multiple other users. Users can also quickly scale up and down computing resources when needed. Cloud service is a pay-as-you-go system where you pay for what you use. Cloud services have several advantages. First, the cloud is economically advantageous because it only needs to use computing resources in the required amount and for the required period. Second, computing resources can be used very flexibly by adjusting their size as needed. Third, even if some hardware fails, cloud providers have a system that can continuously provide services. So, cloud availability is excellent. Fourth, since the user only borrows and uses the computing resources provided by the cloud, the construction time can be minimized. The cloud services could be classified as Sas, PaaS, and IaaS. Sas is a software as a service, is a service that provides application software, and PaaS is a platform as a service, is a service that provides a software development environment. The IaaS is an infrastructure as a service, is a service that provides IT infrastructure, for example, server, storage, network, etc. In addition to SaaS, PaaS, and IaaS, various types of cloud services are occurring as a service. Security solution service is called SecAS, Security as a Service. Desktop service is called Desktop as a Service. Database service is called DB as a Service. And the storage service is called ST as a Service. The fact that such a variety of as-a-service is occurring means that the utility value that the service gives to users is great. It is expected that more diverse types of as-a-service will be provided in the future. The cloud market has been growing rapidly since 2010. In particular, the growth of the SaaS market is explosive, and the PaaS and the IaaS markets have not grown significantly. The BPaaS means business process as a service market is expected to grow rapidly in the future, especially the public cloud market size is expected to exceed the $300 billion by 2025. This is Gartner's cloud hype cycle. In this figure, we can see some important patterns in cloud technology. First, cloud-connected technologies are on the rise as clouds become more diverse and patterns of use increase. The connection between clouds becomes an important concern. Second, as time goes by, container technology is becoming a core technology. Container technology is described later. The third, the latest technologies such as IoT and AI, blockchain, robotics are converging based on the cloud. The cloud is becoming the basis for the latest technologies to be utilized. Almost all SaaS is developed based on PaaS. Therefore, once developed SaaS is inevitably independent on PaaS. Developers don't want their SaaS to be tied to the PaaS of a particular large enterprise. Therefore, there is a tendency to prefer PaaS based on open source. Open source based PaaS such as Cloud Foundry and OpenShift are gaining popularity because of this. According to the cloud operation method, it can be divided into private cloud, public cloud, and hybrid cloud. The private cloud is a type that companies or institutions build and use internally, and it is a form of providing limited services to insiders by configuring a cloud service environment inside companies and institutions. The private cloud is better for guarantee the secure and privacy. And the public cloud is a type that utilizes the services of an external cloud provider, and the multiple service users use a service for an unspecified number of people, and the public cloud is a general pattern for a cloud. The hybrid cloud is a type that combines private and public for security and cost reduction and agility. There are also community clouds which are controlled and used by groups of organizations. They share a common interest such as a spatial security needs or a common mission. Multi-cloud is a form in which one company or institution use various clouds for the purpose. Each cloud has its own characteristics, and multi-cloud is one that seeks to maximize the advantages of each cloud. The Ppp Cloud means public-private partnership cloud is a method of bringing the cloud system built in the public cloud to the inside of the company and building it in the form of a private cloud. It can be seen as a form that combines the stability of a public cloud with the security of a private cloud. So the Ppp Cloud now get the interest of the many institutions because it guarantees the security and the convenience to implement. Edge cloud is a method in which the cloud is placed in the form of an edge cloud near where a lot of data such as IoT or autonomous driving is generated, and data is collected or processed first, and main data is processed in the main cloud. It can be considered advantageous when the amount of data generated is large. In traditional IT systems, companies had to purchase, manage, and operate everything from hardware to software. This traditional method requires huge maintenance cost and highly skilled technical personnel. However, as the IaaS, PaaS, and the SaaS types of cloud were introduced to companies, the range of IT resources that companies actually had to manage rapidly decreased, which led to cost savings. IaaS is a model that provides computing resources such as CPU or hardware, server, storage, etc. as a service through a network. IaaS is a method of providing flexible computing infrastructure to users by virtualizing physical resources. In this figure, if you use one machine as a whole, you can use only one specific operating system, abbreviatedly OS, but virtualization allows you to use various operating systems on one machine, and the use efficiency of the machine can be greatly improved. I will briefly explain the types of IaaS virtualization. The hypervisor is a traditional virtualization method, and it is a structure in which a hypervisor is installed on one OS, and various OS to be used on it are installed and used. OS installed on the hypervisor are called guest OS, and they constitute a virtual machine. The container is based on the technology called Docker, and it implements the form of a virtual machine with only essential binaries and libraries to run any application. This is called a container. As shown in the figure, containers are very simple compared to the hypervisor method, run faster, and occupy less memory, so they are very popular among cloud operators or providers in recent years. PaaS is a model that provides a company's application execution environment and application development environment as a service. In PaaS, an application execution environment or database is prepared in advance so that an application can be developed in a short period of time to provide a service. PaaS has several advantages. In particular, since the entire development environment is provided, developers do not need to build a development environment. Also, if you use PaaS, the life cycle from development to deployment is short, making it easy to apply Devops. Devops is a synthesis word of development and operations. For cloud development, the organization for development and operations should be merged for developing cloud software. So DevOps is a very important issue in now the companies, and it is a culture and the system for development and operations. And I will explain it later. Developers can focus on developing apps using PaaS. When developing an application using PaaS, developers are provided with the necessary development tools in the form of a service through PaaS. Developers can find suitable tools in the PaaS marketplace and use them for development, which can dramatically reduce development time and effort. SaaS is the provision of software as a service. In other words, SaaS providers prepare the hardware and the platform to run the software right away and make the software available to users immediately if they want. As long as SaaS users are connected to a network, they can use it right away without installing any software. In order for users to use SaaS, they need to sign up for a SaaS service subscription and be assigned an account. In order to use SaaS, users must be able to connect to the network. Users pay the SaaS usage fee in a flat rate or pay-as-you-go basis. I would like to explain the technical characteristics of SaaS. When a user receives a SaaS account, they are assigned a tenant, which is the space used for the SaaS. A tenant is a logically independent computing space for users. Users can utilize the software in their own proprietary form that within the tenant. In the tenant space, users' data is protected, the availability and the scalability of software usage can be granted, and the user pays for the amount of software used. This figure allows us to compare smartphone apps and cloud SaaS. A smartphone app is a structure in which an app is downloaded from an app store and used. Therefore, the user uses the smartphone app in an independent space. And on the other hand, SaaS is a structure in which users are allocated a space called a tenant in the cloud and use the app. Apps in the cloud are shared by users but are logically independent. This figure shows the structure of utilizing SaaS in more detail. When a SaaS developer develops an application and put it on the marketplace, SaaS users apply for a SaaS subscription, receive an account from the cloud, and use the SaaS. At this time, SaaS can be shared among users, but each user uses the app independently within the tenant. App users pay monthly app usage fees to SaaS developers through the platform. I will explain the future of the cloud and the leverage strategies in part 2. The cloud has passed through the first generation focusing on IaaS and the second generation utilizing IaaS PaaS SaaS. Currently, we are living in the third generation cloud era where almost everything we think of is serviced. In the third generation cloud, advanced IT such as AR, VR, IoT, machine learning, robotics, and blockchain, and even artificial satellites are provided as services. Currently, the cloud technology has 4 major pros. First, all technologies are converging based on the cloud. Second, There is a growing demand for cloud connectivity, that is multi-cloud or hybrid cloud. Third, as the size of data such as autonomous driving and the IoT increases, there is a growing tendency to place an edge cloud near where data is generated. Fourth, there is a growing tendency to develop software natively suited to the cloud. We want to look at the fourth most important pro here. Cloud-native applications are software developed for the cloud. Since cloud applications, that is SaaS, are basically in the form of a service, the most basic concept is to make the elements that make up the app in the form of a service as well. In other words, the basic purpose of cloud-native apps is to maximize performance and development benefits by making the components of the app into an independent service and mashing them up according to the situation so that the SaaS operates. Four elements are essential to constructing a cloud-native application. First, microservices. It makes the elements constituting SaaS in the form of microservices so that they can be operated and managed independently. Second, it is the container in which the microservice runs. Containers are the best way for microservices to operate independently. Third, continuous deliberation. This makes it very easy to deploy your application to the cloud by automating the whole process when upgrading or developing SaaS. Fourth, Devops. This unites development and operations into one organization, allowing apps to evolve as they continue to be upgraded and managed. Traditional software has been developed in a monolithic way, so if some part of the software had a problem, it had to be operated in the form of stopping the entire software, fixing it, and then restarting it. However, with the introduction of microservices, it is no longer necessary to fix the problematic microservice and stop the entire software. Because of this, microservices are attracting attention as a state-of-the-art architecture that dramatically increase the agility of software. In a microservice architecture, each service utilizes an independent database. In other words, each service operates completely independently. When sending and receiving data between services, a very lightweight interface called REST is used. A microservice architecture is best suited to the realistic needs of utilizing computing resources over a network. In the existing software, when the process was extended due to the increase in users, the process was expanded in units of process. But in microservice architecture, only the functions that need to be increased within the process need to be expanded. In other words, when the number of users increased and the server or virtual machine was expanded, it was necessary to expand the entire application unit. However, if you use microservice architecture, you can scale up much more precisely because you can expand in units of microservice within the application. The open cloud platform, we called it PASTA, was developed for the purpose of reading the domestic PaaS standard, developing an open source-based PaaS ecosystem, developing the domestic software industry, and developing the public cloud environment. It is being used in Korea's e-government and the private cloud industries, and it is dramatically improving the competitiveness of Korea's cloud platform. Since Pasta is an open source base, anyone can use it for free, and it is open to the public on GitHub. Pasta was first made in 2015 through ISP in 2014 and has been continuously upgraded since then. Currently, version 6 annually was released in 2021. Pasta is a combination of 71 software based on an open source, including Cloud Foundry, and it is released as an open source on GitHub. Pasta can be divided into core functions that support the execution of Sas and the development and management tools for developers, users, and operators. Development of an open source PaaS, verification and stabilization for core functions has been completed, and the development of various IaaS support standards, frameworks, and domestic software installations have been completed. A user portal or management tools that supports the operator's usage measurement, monitoring, and operation control has been developed. Pasta consists of a platform for application development and execution and a platform for container execution. The application platform is based on Cloud Foundry, and the container platform is based on Kubernetes open source. This picture shows the application form of Pasta. Developers use the application platform to develop apps and store images of those apps. When developers run an application, it is developed in a structure that utilizes Kubernetes and containers to run it. Pasta provides various types of CPI, which is called Cloud Provider Interface for interworking with IaaS. Pasta enables rapid development and testing of application software by automating standardized hardware and software development and the execution environment within minutes. In other words, Pasta automates the installation and the configuration of standardized software such as a framework, middleware, and the operating system required for application development, dramatically reducing the time it takes to develop and test the software. Pasta can guarantee high availability at the hardware and the software level by responding to failures based on integrated monitoring of the operation status. IaaS guarantees high availability at the hardware level through automation of monitoring and failure response for virtual machines, wherever Pasta guarantees high availability at the software level through automation of monitoring and failure response for containers running on virtual machines. Because of these advantages of Pasta, the use of Pasta is continuously spreading in central administrative agencies, public institutions, local government, and the national and public universities in Korea. It is expected to become popular in Korea. Major global cloud companies are applying the latest IT technologies, especially artificial intelligence, big data, IoT, and blockchain technologies to the cloud. and are providing cloud-based services. In the future, in the era of technology convergence, this trend of the cloud is expected to increase, and completely new forms of IT, new technologies will be derived through the convergence technology. Korea's central administration, public institutions, and local governments are intertwined with each other in an organic relationship, and compatibility and interoperability are very important issues in data, communication, and process. Therefore, even if the types of clouds used by institutions are different, it is essential to adopt an interoperable platform, and as a result, efforts to ensure interoperability between clouds through PASTA are increasing. In addition, there is a growing tendency to share data and systems with each other through platforms that are the basis for using artificial intelligence, big data, IoT, and blockchain in each industry or companies. This demand can be solved through one open cloud platform, and PASTA is the best alternative to support it. PASTA is already being used as a standard cloud platform for the central government. There are also many companies that need it and use it. PASTA was born with the effort of the government, but it continues to develop through the efforts of a number of related companies, individual developers, and the communities. The latest technologies are being grafted onto PASTA, and the technical support is provided free of charge to countries in need. Through these efforts, cloud platform technology will be positioned as the most core infrastructure of IT technology. Thank you for your attention. If you have any questions, please contact me, and yes, I will let you know about my email address for the organization, and you can feel free to contact me, and I will answer you sincerely. Thank you very much.